How is it proven no Pythagorean triple has all prime numbers? Imagine a right triangle with three sides that are all prime numbers. It sounds interesting, but is it actually possible? Let's look into how mathematicians have shown this can't happen. A Pythagorean triple is three positive whole numbers that fit the equation a squared plus b squared equals c squared. These numbers representing the sides of a right triangle. When these three numbers share no common divisor other than 1, the triple is called primitive. Now, the question is, can all three sides be prime numbers? First, in any Pythagorean triple, at least one of the numbers must be even. This is because the sum of two odd squares is always even but not divisible by 4, which is necessary for the hypotenuse squared. Since all prime numbers except 2 are odd, the even number in the triple must be 2 if all three were prime. But here is the catch. If 2 is one of the sides, then the other two sides must satisfy the equation 2 squared plus some prime number squared equals another prime squared. That is for plus some prime squared equals a prime squared. When you check this with modular arithmetic, especially modulo 8, it turns out that this cannot happen with integers. In fact, the number 2 cannot be part of a Pythagorean triple as a side length. This is because the equation would not hold true for any prime numbers other than 2. And since 2 cannot be part of a Pythagorean triple, it rules out the possibility of all three sides being prime. Now, looking at the formulas used to generate Pythagorean triples, they involve two numbers called k and l. These formulas are A equals k squared minus l squared, b equals 2 times k times l, and c equals k squared plus l squared. Notice that the side b is always 2 times k times l, which makes it even and usually composite unless one of those numbers is 1. But if one of them is 1, then the side b is 2, which is prime, but the other sides won't be prime in that case. So, because the side b is always even and often composite, and because 2 cannot be a side in a Pythagorean triple, it is impossible for all three sides to be prime numbers. At most, 2 sides can be prime, but not all three. In summary, the key points are that one side must be even in any Pythagorean triple. The only even prime is 2, which cannot be part of such a triple. And the formulas for generating these triples show that the even side is always composite, unless special conditions are met. This combination of number theory and geometric reasoning proves that no Pythagorean triple can have all three sides as prime numbers.